Hi everyone, welcome back to HackConf 2021. I'm Krasi and it's time to introduce you to our second lecturer for today. His name is Atanas Kuzmanov and he's a senior software engineer in Schwarz IT Bulgaria. He has over 10 years of experience in the software industry, 5 of which he had even spent working for the BBC. He had successfully led large-scale projects involving cross-domain collaboration. And today, he's going to present to us what is APIFirst and ContractFirst Development and why it is beneficial and why we should use it. Atanas, the half online stage is yours.
Thank you so much, Krasi, for the wonderful introduction.
Yep.
Hi, everyone, and welcome to my talk about APIFirst, ContractFirst, and making API development great again. So, my name is Atanas, and here's a bit of background about me. I'm a senior software engineer at Schwarz IT, and here, basically, what I do there is I'm part of the IT solutions development department, and we maintain and develop our property management system, CMS, among other systems. And why am I here, and why am I giving you this talk today? So basically, I was given a task that I finished quicker, and I was crying out for work. And my colleagues gave me a task, I guess, as a bit of a joke or maybe a bit of a challenge, something that they had attempted to solve a couple of years ago, and they were unable to. And that was for a good reason. The technology really wasn't quite there yet. So I was unaware of this, and I attempted the task. I struggled with it, but then I managed to solve it. So that's why I'm here to tell you about it today, because I think it's practical, it's immediately applicable. The technology itself isn't that new, but the way I think I'll show you how to use it, I think is innovative, and I hope you like it and you find it useful. So let's have a brief look at our agenda. I'll start with an introduction and a few basics just because I want this talk to be accessible to everybody. So we'll start discussing basically what is an API. Then we'll go through design first versus code first and how that applies to building APIs. And then we'll tie this whole thing neatly into a live demo with the tools that you need for the job. So hopefully we'll have some time for Q&A as well. So first of all, small disclosure, if you're here for the IPAs, you're in the right place, but the wrong time. So APIs now and IPAs later. Also, another small disclosure. So I'll be using the following brain focus technique I learned from the Headfirst books and an ex-colleague of mine. Shout out to Ian Funley if he's listening. So the presentation has more text than usual, and that's on purpose. Normally, when I'm a viewer and when I'm rewatching presentations, I like to pause and read the slides. So that's why I'll be showing you random move facts throughout the presentation. The idea of this is to give some time to your brain to breathe and then to bring you right back into the presentation. And I think the wolves are a noble creature. They're driven to extinction in a lot of countries. So I personally have done a small donation to the Euronatur German charity because one of its doings is protecting the wolves in Europe. I normally don't tend to stick to any particular charities when I'm donating, but in this case, because I'm using wolves in the presentation, I chose this one. So let's get started. So first of all, what is an API? An API stands for an application programming interface. And it's a software or a type of software that offers services to other pieces of software. It's an interface which allows two programs to talk to each other. So, for example, if you're using Facebook on your phone or checking the weather, all of that is happening via API. You're using APIs. And if we think of a simple example, so let's say that you're in a restaurant, you're reading the menu, and you want to order food to the kitchen. And the kitchen will be the server. You will be the client ordering the menu, and the critical bit missing is the API, in this case, the waiter. He'll give your order to the waiter, he'll bring your order to the kitchen, and then the kitchen, or the server, will take your order and will prepare it for you. We'll give it to the waiter to give it back to you, in which case it will be your response or your food. So imagine the following scenario. You want to access all the Twitter tweets that have the hashtag OpenAPI. Now, you could email Twitter and ask them to send you a spreadsheet of all of those tweets, but that's not really feasible. By the time you get it, it will be out of date. You'll still need to find a way to import it in your app. And again, it will be out of date by the time you do it. So it's much better that Twitter provides you a way that you can query their application. And that happens via an API. So imagine another scenario. Imagine that you're in a team that's building Twitter. You have two teams, a front end and a back end. And you need to build the two things in parallel. You can't wait for one to be built rather than the other. So In this case, here is where API contracts and API development comes in. Imagine that you're giving a contract which describes, or a document which describes how to build the API, so that if you build the front end and back end in parallel, they'll be able to talk to each other when you go live. And such a document is called an API specification or an API contract. So, like I said, the communication between backend and front end will happen over APIs. And if the teams adhere to the contracts when they go live, their APIs will be either able to talk to each other, or they will fail and they won't be able to talk to each other if they don't adhere to the contract. So in the current situation of increased remote working, having a common simple medium of communication, I think, is indispensable, such as OpenAPI, when you build your APIs or when you want to achieve your goals. And I think it's very exciting when such a document, a text document in YAML or JSON, can serve as a contract, can generate client servers and documentation in a plethora of languages, put your developers and clients first, have automatic fail-fast validation, is cross-platform and language agnostic, is both human and machine readable in YAML or JSON, and speeds up development, prototyping, and saves cost. So when building software, there are several approaches you can take. And first, let's discuss at a high level design first versus code first development. So with the code first approach, you start with your IDE and you're typing out some code. Somewhere at the back of your mind, you know that eventually an interface will be created to deliver this service. But it's the core functionality that's driving the implementation rather than the core service. So when you get to build the API, which is going to deliver that to the customer, it might not feel very well built. It might feel like it was tacked on, like an afterthought, and the user experience might not be great for everyone who will be consuming your API. So in comparison with the API-first approach, instead of starting with the code, you start with mocks, developments, tests, ideas about the API, and this process is aligned with agile software development. It's much more lean. It allows the team and any stakeholders, technical and non-technical, to weigh in on the process early and often, and to give feedback before a lot of time and effort has been sunk into the project, which I think is great. So let's drill down a little bit deeper and talk about design first versus code first in terms of API. So like any product, the idea starts with an idea and the plan to capitalize on it. And from there, you have basically two approaches. You can either use the design first approach, designing the API and contract before writing any of the code. Then you can agree on it, solidify it, and then get set on developing it. Or you can start with the code first approach. And there are pros and cons to both approaches. So before we look into them, random wolf facts. So once a wolf has found a mate, they tend to stay together for better or worse, through thick and thickness, through sickness and health, often till death do them part. They have been known to sacrifice themselves for other wolves. So move over, Romeo and Juliet, there's a new couple in town. Right, so let's look at some advantages and disadvantages. So with the code-first approach, code-first doesn't mean leaving out the design altogether. It means that rather it's hidden away in Jira tickets, Confluence pages, text documents, and potentially lost to history forever. So this can lead to some potential problems. You can have frustrated users, the wrong API could be built, or missed opportunities. If people don't know about your API, they can duplicate the work building the same thing. And now let's look at some benefits. Obviously, when delivery speed matters, if that's an important success factor for you, you just need to start coding directly. And also, if you're developing like a small tool and a small API that's just for your team or internal use and everybody are aware of it, yeah, code first is the ideal approach for you. Now, challenges of the design first approach, well, it's hard work. So to be honest, it takes a lot of time and deliberation for any team to move to a design first approach. And then it takes commitment. Companies must be intentional on moving to design first, no matter their size. It doesn't happen on its own, and it doesn't happen overnight. So now let's concentrate on the benefits of the design first approach, which far outweigh any possible challenges. So you have product-driven APIs. You're working in parallel. All teams can set to work on it using one contract, and you get immediately shorter feedback loop. Things fail, and you know where they failed and why. And also, you can view your contract as a source of truth for everyone, including DevOps teams. And when you're delivering mission-critical APIs for external clients, the user experience of those APIs, it will matter. It will be important to you. So another random wolf fact. So it's all in the howl. Wolves do howl at night, and these soulful howls have nothing to do with the moon, like most people think that they howl at the moon. These penetratingly, hauntingly beautiful howls is a primary communication tool between either lone wolves or between their packs. So we can already see that the design-first approach is the far better approach. But why? Let's see why. So in a world where speed to market hold premium, why would you spend valuable building time in building the API first rather than the code. Is it worth it? Well, there are several benefits, and some of them are earlier validation, clear abstraction layer, decoupling dependencies, and ensures quality and predictability to withstand web clients and other developers, which will be using your APIs. So a couple of real-world examples. Twilio is the whole platform which is API first. It's built for all of their clients which are using the API and is developed entirely API first. Speaking from personal experience when working at the BBC, building a new breaking tools app in time for early elections in a cross-team platform of 3 different teams across 4 different locations, it was a challenge, and our main communication channel was an API contract. Without it, we wouldn't have been able to make it in time. And again, speaking from personal experience at Schwartz IT, we use spec-first API design and have seen some great benefits to it. Basically, all of our backend services have API REST projects accompanying them, and currently most of them are in Java, but we're slowly moving them to OpenAPI, and we use it for any new projects that we start. So your contract is your API. And what is an API contract? It's a shared articulation of what an API does, both in human and machine-readable format. So it uses tools such as OpenAPI to describe the requests and responses of each functionality. Basically, what are your methods? What kind of parameters do you have? It's something that both API providers and consumers agree upon, and then they get set on to building it for an agreed upon price usually. And also, an API contract helps mitigate change or at least communicate it. So if you're implementing a change, sending an API contract before you implement the change, it allows your consumer to review it and then to either agree to it or to disagree to it. And that all sounds great and all, but there is usually no way to enforce a contract. And this sometimes, or more often than so, has monstrous results. If only there was any way or any relevant tools to change this. Well, enter ContractFirst Development and contract validation and testing. So what is this ContractFirst Development thing? Well, ContractFirst Development is about making your intent clear across the team and any stakeholders in the beginning. So by using a tool like OpenAPI, you can define your API and clearly at the outset and show it to everyone. You can also update any contract before you implement any changes so that everyone agree to them and they can commit to them beforehand. And what is this contract testing thing? So this is the way that you enforce contract. This is here is the innovative part where you have automatic validation of set contracts. When compared to end-to-end testing, for example, the contract testing enables you to create more consistent curves that look more like the chart below, and they maintain the effort and complexity relatively low. So how do I convince you? Well, the main thing that any organization comes when building software is the cost. And when building software, your time is probably the biggest cost to an organization. So there will be an issue overhead, but using contract tests in conjunction or as a replacement to end-to-end testing in the long run will be cheaper in the long run, basically. And it saves basically cost by several things. It provides very fast feedback loops. It's clearly identifying a problem when they fail. And it ensures that only the parts of the API that will be used get actually built and developed. Also, they often save computing time and resources. So another fact, wolves are a keystone species according to most ecologists, and wolves help to regulate the systems by preventing hoofed herds overpopulation better than us humans do anyway. There is no valid reason to kill them, they're not used for food, they're not overpopulated, they're not a significant threat to cattle, and they're not a significant risk to human safety. Now tooling. So we're going to need the right tools for the job. So let's see. First of all, of course, OpenAPI. It's the tool that you use, it's a standard to describe your API in YAML or JSON and everything that you need for it. Parameters, methods, requests. Basically, here is an example of the anatomy of an example OpenAPI spec. I've highlighted a few pieces of interest where you specify your paths, requests, parameters. And the really cool bit is that you have the option to define a schema, which helps you keep the dry rule. Basically, do not repeat yourself. So if you have an object, you can say that it has an ID, which is an integer, name, string, etc., etc. Next, Swagger. Well, you're probably familiar. It's built around OpenAPI spec. And once you have a spec, you can pretty much use it to generate clients, servers, stubs, and also documentation, because, correct me if I'm wrong, but often us developers forget documentation. So probably some of these sound familiar. So code first, document later, or we write documents when we have time. Almost definitely, for sure. Maybe. So yeah, I've personally done that as well. Guilty. So the next thing we need is an OpenAPI generator. When you have a document, an OpenAPI spec, you pass it to that generator and you use it to generate code, servers, and stubs. And that's basically what Swagger is using in the background. There are several versions, and we'll be using one or two of them in the demo. So next, here's a really important bit of kit we need. So after spending a lot of time researching how I can do request and response validation for our APIs without having to rewrite old tests, write a whole new project, a whole suite, or like basically spend a lot of time working on it, I found the answer. And Atlassian has done it for us. They've built the request validator Java library, which basically provides facilities for validating requests and responses. It has several modules, and I'll be using the Rest Assured module for our demo. So next, we need some tools for validating the front end. And here are just a couple of Node.js Express validators, and I believe I'll be using one of them again in the live coding demo. Well, we have the usual suspects. For the demo, we'll need a little bit of Java, Spring Boot, JavaScript, TypeScript, Angular, MongoDB, and Docker just to get the whole thing running. Random wolf fact. So the wolf represents strength, loyalty, family ties, caring, and expresses freedom and fortitude. In Japanese, the word for wolf, okami, means great god. So pretty cool creature. And now it's time for demo. So first, I just want to go over what we will do in the demo. We're going to use an OpenAPI spec, and we'll use it to generate our backend in Java and Spring Boot. We'll use the same code in an OpenAPI generator to generate our front-end client in JavaScript and Angular. We use Atlassian's validator to validate the backend server. Then we use the front-end validator to validate the front-end server. And we'll demonstrate how tests fail if we breach our contract. This is where the innovative bit will be. We'll have automatic validation of our APIs. So, well, as we all know, with live demos, fingers crossed that everything will work. And hopefully you should be able to see my screen now. So first of all, here is an example of an OpenAPI spec document, and this is an API specification for an online pet store. A very basic CRUD application for creating, deleting, removing pets, everything that you need, basically. It's free, it's available online. It's pretty long, it's 800 lines long, so I'm not going to go into it, but it's provided by OpenAPI, by Swagger, and you can look at it on your own. And then we have the exact same document, just in JSON and in YAML, because we need both of them for the different libraries. So if we head over to the terminal, let's see what we can do with this basically YAML file. So, So here I'm in the directory with the two files that I just showed you, and I'm going to issue the following command to the OpenAPI generator. I'll pass the spec, the API spec file, and I'll tell it that I want it to generate a Spring Boot Java project for me. And let's see if that works. Okay, so it's done something. And if we look in the directory, it's generated a folder. If we go into it, if we move back to our IDE, we'll see that now it's generated a full-blown Java project for us. And all of that is just from a text document. So we have models, we have configurations, we have an API, we have controllers, we have like an application, a main application project, and basically a lot of stuff. And all of that is already saving us development time because it's automatically generated. Let's see how cool or powerful this really is. So what if I do Maven clean install? Will this build? Will this compile? I mean, it's just code generated just from a text document, right? From a YAML file. Well, this builds. And what if I say Maven Spring Boot run? Do you think that this will run? Let's have a look. So this seems to be running. And if I go to localhost and see if this backend project is running, boom. We've got like an OpenAPI, an API generated from our OpenAPI. At the moment, it won't work because it probably needs a MongoDB or something in the backend to talk to the database. So we'll see a few exceptions that it can't connect to the database. Now, this is already pretty powerful stuff. But let's go and do something for the front end. Sorry. So if I go, I'm still in the same directory. And basically what I'll do is I'll just call Angular to generate a very basic empty Angular project for me. So I'll just answer yes, yes, CSS is fine. Now, I'm going to stop it at this point because npm install on my machine going through proxies and various stuff will take forever and will totally defeat the purpose of the demo. But if we go back into the IDE and we have a look, now it's generated for us a full-blown, well, a basic Angular app. So you have an app, you have like your normal files, etc., etc. But if you think about it, I still haven't used the OpenAPI generator. I've just generated an empty Angular project. And that's for a good reason, because now what we'll do is we'll go back into the terminal and we'll issue a different command to a different generator, a front-end generator, but we'll use the exact same API contract file. And we'll say, OK, generate an API for me for the front-end so that the front-end will be able to talk to the back-end. So if we go back and look in the IDE, we'll see that now an API folder has appeared, and basically it has generated a full-blown API for our online pet store. It has services, models, and a whole bunch of other stuff and code, which should, in theory, allow us to talk to each other. Now, the thing is that, as it is normally with live demos, things go wrong, and also I interrupted the npm install because it will take forever. So I've tried to be as best prepared as possible, and we still need some glue code to actually make the two applications talk to each other. So instead, what I've done is I've prepared the exact two same projects, the Angular frontend and the Spring backend, with the only difference that I've added a few controllers, a few backend connections, and a few front-end routes, for example, the normal routes that you do in Angular, just so that the two applications can talk to each other. You'll be able to eventually check this code when I clean it up in my GitHub repos, and you'll be able to compare the results and see that there's only very little code added. So now I'm going to switch over, and I'm just going to run the applications, only this time with the glue code already in place. So Maven Spring Run, and yep. Also, we will probably need, like I said, some kind of a Docker with a small Mongo database. So let's just run that, and hopefully, if we go to Docker, we should see, yeah, here's a very small MongoDB for us. If I connect to it, or rather if I refresh my connections, yeah, we've got a small database which is currently empty now. OK, so far so good. Let's refresh the backend. So that's still working, and we have our full-blown API. And let's try the front end. Oops, of course, I actually still haven't run the front end. So let's do ng serve. Yeah, just giving it a little bit of time to get going. OK, so while it's preparing to go, let's maybe just prepare with an example test. So now we've not only generated an API, but it's kind of already functional. We've added a little bit of glue code so that we can talk to the backend, and the backend can talk to the front end, and the backend can talk to a database. So in theory, we should be able to make requests and responses, and actually try out our API, which was generated just from a text document in the browser. So hopefully by now the front end should have loaded. Yeah, there we go. So we have a front end for our online pet store. So again, let's try it out. Let's see if any of this actually works and it can talk to each other. So here I'm just going to paste just a very simple example of an online pet for the online pet store. So let's just change the example to a dog called Dodge or something like that. And if I execute this request, let's see if so we have a 201, so hopefully the thing should have been saved in the database. And if I refresh the online pet store, we have a dog. My name is Dodge, and I'm available for purchase. So this is actually pretty innovative so far, because out from a text document, we've built a front end, a back end with just writing a few lines of glue code. But now let's get to the really cool stuff. So here I've also added, other than the glue code, I've added a little bit of a test. So this is an OpenAPI validation test. And it's using the rest assured library, like I mentioned. But basically what it's doing is it's reading the OpenAPI spec file in JSON, the one that I used to generate this whole code. And then it's testing an endpoint. So we're testing the pet endpoint. And if we run this test, hopefully, everything should pass. So this should validate that our code and our API is correct and is according to the contract specification. So it should test it against this contract here. And hopefully the test should pass. And we can see, yeah, so the test, it has read our contract and it has validated our code and our API against it. Well, but let's imagine that I am the client and I change my requirements. So now I change the contract and I've changed this endpoint. And I'm giving to the team this new requirement, this new contract. And what you do is you just run the test again. And this way you can now you have the new requirements and you immediately get a fast feedback loop of what parts in your code need to change, because the test in theory now should fail. Oops, well, it passed again. So something I'm probably changing the wrong document, or I have the wrong thing open. That's always the case with the live demos. Let me see. Yes, so sorry, I changed the YAML file, of course, and I'm using the JSON file for the test. Well, I'll change the JSON file, and now I'll rerun the test, and now it should fail. So as you can see here, I am using indeed the JSON file. So here it goes. And yeah, well, the test failed, and it's telling me exactly that. It's telling me that it failed because I don't have such an endpoint in my API. So if I go back to the JSON and I can either fix the JSON or I can change my code. It will now, the test will pass successfully. And then there's the other side of the coin as well. So let's say that I intentionally or just by mistake, I make a mistake when I'm implementing the API. I'm writing code and mistakes happen, or I just change something on purpose from the API. And I'm going on integration, for example. I'm deploying to int or test or even production. And this is where my pipeline should fail because I violated the contract. So basically, and there we go. So the test failed, and it's telling me you've changed the API, and your code no longer conforms to the contract. You've done a mistake, so you need to either fix it or fix the contract. And this is really the innovative bit. It allows you to validate the code that you write according to the specification, according to a text document that everyone can share around. And if I rerun the test, it will pass again. I fix the code. And now, for the next bit, is we have the exact same kind of validation, but for the front end. So I've written like a small JSON file, which is doing the exact same thing. It's testing an endpoint both at the mock backend and at the live backend. And what it is using, hold on, sorry, I have, because the monitor is a bit further than me, I'm having some trouble in seeing the, okay, here we go. Here is the test file. So yeah, it's basically doing the same thing on the front end. It's reading, this time I'm using the YAML file because that's what the Express.js library is using. And I'm validating the backend, both real time and like a mock backend as well. So if we go back to the console, so the front end is running, and let's go to Angular, and let's just say we want to run the test. So let's just say npm test, or rather run test Mocha. So I'm using Mocha for this test. So we can run it and we can see that both of the tests are passing. So that's great. My API is valid. But now if I go and do the same thing, if I change the contract, and if I run the tests again, hopefully they should fail, and they tell me exactly that. I've breached the contract for the front end. My API is failing. I either need to fix the contract or fix my code. And this is, again, this is the thing that really excites me. This is the innovative bit. Basically, out of a text document written in YAML or written in JSON, I've generated a backend, I've generated a front end, and I've also have a way of validating both of these projects. If they're two separate teams, they can validate, they can build the same thing in parallel, and they can be sure that when they go into production, their APIs will be able to talk to each other. So back to the presentation. Just a recap is exactly what I just said. We use just a text document to generate a front end, to generate a back end, and then to validate both of them if they're according to specification. So I'd like to leave you with the lyrics from the song Everything Counts by Depeche Mode. The handshake seals the contract. From the contract, there is no turning back. The holiday was fun-packed. The contract still intact. So people, keep your contracts intact for your APIs. References, here are a bunch of references, everything that I've used for the code, for the presentation, and I'm open to your questions.
Thank you, Atanas, for the great talk and for the many interesting facts about wolves.
Thank you. Yeah.
Yeah, we learned a lot of new stuff around there. We've got questions in here.
Cool.
So, does it work with other libraries than Rest Assured?
Yes, it definitely does. So I am using Atlassian's code. So when I started researching it, when I was approaching this task, there wasn't any blog spots or any tutorials. So I had to reverse engineer a bit the Atlassian's code, but they provide other modules for REST templates and for WireMock and for basically a bunch of other stuff other than Rest Assured. So yeah, definitely it does work for other libraries.
All right. So you've shared many reasons why we should be using APIFirst and ContractFirst Development. Let's imagine that we've got a project that is already built in and haven't followed all of this stuff. So how would we interact? How would we start using these APIFirst and ContractFirst development?
Sure. Well, that was exactly the situation that I was in. Our project was already built, and I had to introduce this validation, this testing for our backend. So the way to do it is first to start by going through your existing code, through your existing API, and you start either manually or automatically. You can use Swagger. You need to generate some kind of an API specification of your existing code. And once you do that, then you can introduce, for example, in my case, it was Java. Then you can use the set Java libraries to actually start validating your API according to the spec that you've just written. So then you have your code, your new API specification, and going forward, any changes that you make will be protected by that contract. You'll be going forward, once you have solidified your contract, you'll be able to use it for other clients or for your own development. If you make change to the code, you make change to the contract, or vice versa. You make change to the contract, you implement it in the code.
Yeah, I understand. Have you tried running this on the CI, or when do you run all of these validations?
Well, I think they're best suited as integration tests rather than unit tests. So they do run on our CIs. It's when you run integration tests. So if you deploy to integration environment or test, the test run and your build either succeeds or it fails. And also, of course, locally. I mean, you can run them locally.
Yeah, locally, of course. Can we generate GraphQL client and server through OpenAPI by simply defining the schema?
I'm not sure about this one. So I haven't thought about this one because GraphQL normally breaks the REST protocols and the REST, formats and the REST stuff. So I'm not really sure about GraphQL. You can probably try it, but you won't conform to REST. You can probably try it. It might be a bit tricky to specify your responses and requests. Yeah, maybe you can probably try it. Actually, that would be interesting. Like, let me know if you do it for GraphQL.
Yeah, you can use our channel in Discord for discussions, by the way.
Yeah,
you can discuss it there and share it with us, as we would already we would also like to know it. All right. Can you use it for real life validation?
You can definitely. It would be better if you're starting from scratch and you build everything API first, because so I've tried to use it for real-time validation, and you get probably a bit more errors that you should be comfortable with, and it's quite a bit more work to get around them because you already have existing request responses. You might even, if you have a front end, you might have some things with downloading CSS and errors about that when your app runs. So it might be trickier if you already have a code built, but you can run it online. I mean, definitely in the backend in Java, you can for example, there is a module about the REST templates. So if you're using REST templates or any new implementations or something like that, you can plug it in the REST template as an interceptor.
All right, and I remember that we talked about Swagger. So have you used some other tools than Swagger, and how did you choose Swagger?
So I haven't used other tools but Swagger, but I'm aware that there are other tools that support OpenAPI validation other than Swagger. I've used Swagger just because it's something that we were already using in the team, and it's something that I'm familiar with, that I like using and enjoy using. But there is, I think, a tool called Pact, which I think is also pretty similar and can do probably the validation for you. So if you're not maybe using Java or any specific front end, maybe you can look into that, and that might be the thing you want to use.
Yeah. All right. Well, I think these are all the questions we've got for Atanas for today. Thank you everyone for watching the second track of HackConf, and we'll get back soon in around 20 minutes. Don't switch the channel, don't switch the tab, and stay with us for the third talk for today.
Right. Thank you as well. Bye, everyone.